Okay, so here is are the steps you want to do when I say, given some genomic sequence, predict by homology how many genes there are. So I start with BLASTn, and I leave this as the default. So it's looking at all the DNA sequences in the database. What does this match? And if I'm lucky, it will match some DNA sequence that I can see where the genes are, but that's not always the case. So the steps would be, you run it with the nucleotide collection. So let's run that. And then you open another window and you run it, the same sequence, and then you narrow it down to the reference RNA. This first step, let's see, you could skip that and you could run just this one. It's just that since this is looking at fewer sequences, you might have fewer answers on this, and maybe that's what you want. But you could do this one and then this one, or just start at the reference RNA, which is telling you, okay, I know that this part of the DNA is sequenced because it matches on mRNA. And the last one would be, does my DNA sequence match protein? But you have to change to BLASTX. And here, the default, you leave it as is, which is your non-redundant protein sequences. But this one takes longer to run. So you don't want to be staring at this. You would run this mostly if I ask you about conserved regions, but in terms of number of genes, this would be the long route. The shortest route would be to narrow down to RNA reference. So in this exercise, I just wanted you to know that there are different ways of doing this. If when you leave it in the overall database, you may get lucky and you may get a result that says it's a gene, but the shortcut is to do RNA reference.